Hello everyone, my name is Suraj Uppal and today I'm presenting my project in which I worked under the guidance of Anuradha Vate ma'am, who is the lead architect of Smart City Living Lab, Triple IT Hyderabad. So let's get started. So the problem with the IoT devices is that data overload. So what happens is that IoT devices generate a vast amount of data, leading to data overload. Managing and analyzing such large volumes of data can be overwhelming, especially if the infrastructure and tools for data processing and storage are not adequately designed. Data quality and reliability is also one of the major issues. IoT data can be prone to inconsistencies, inaccuracies, and noise due to factors like sensor error, network disruptions, and data transmission issues. Ensuring data quality and reliability is crucial for making informed decisions and deriving meaningful insights. As for the inconsistencies and inaccuracies, well, we'll show you those later. In interoperability and standards, IoT devices and platforms use different protocols, communication methods, and data formats. Lack of standardized practice can hinder data integration, making it challenging to aggregate as well as analyze the data more effectively. So, the objective of my project is first of all to perform data transformation, cleaning the data, and then aggregating the clean data. Then I had to develop a dashboard using Grafana to visualize data from various sensors. And the last objective was to develop a deep learning model which can predict the amount of solar energy that can be based on various factors such as relative humidity, air quality index, what is the time during that day. Uh, we can also use data like which month of the year is it, because that also affects the amount of energy generated. And this model is currently still in development, so we are not going to talk about it much in this presentation. So our lab collects data from various IoT sensors. For my purpose of building a dashboard and model later on, I've taken data from the following sensors. One is energy generation nodes, weather monitoring nodes, air quality nodes. The data is gathered from more than one node for each vertical. What we mean by vertical is that let's say there are 50 nodes for energy generation. All those come under one vertical because they tell us about the data of energy generation. For the model, a function has been developed to pass the data and convert it into desirable format for our DL model. Because for the visualization, we'll need data in a different format, and for developing a deep learning model, we'll need data in a different format. Wide range of data sources. So I'm going to first explain like why did we choose Grafana. So these are some reasons that I've stated here. And one is wide range of data sources. Grafana supports integration with a vast array of data sources. It is very interactive and customizable. You can zoom in specific time periods of time series graphs and everything. So that is a huge plus. Scalability and performance. Grafana is designed to handle large scale data. And as we discussed earlier, IoT devices generate a huge amount of data. Integration with DevOps tools, of course, because we also have to deploy these dashboards somewhere, right? So Grafana integrates well with popular DevOps tools and frameworks such as Prometheus, InfluxDB, Elasticsearch, and many others. For my purpose, I wrote queries in PostgreSQL for making these dashboards. So 1M, 2M is like the backbone of all, like the database that like PostgreSQL is a backup of that database. So we are having data in two different databases, but it is the same data, but it is also stored in that one M2M part, and some is also stored in the PostgreSQL. And as for the data cleaning, I use Jupyter notebooks and Python, specifically the Pandas library, because it provides a lot of built-in functions. And all the dashboards were made using Grafana and SQL queries. Later, I have integrated like the dashboards into a web page using HTML. So this is some information about the 1M2M server. 1M2M is an IoT specific architecture that helps to establish communication among various nodes. This architecture consists of application layer, which is like the top of the stack, service layer, and the network layer. So here I have showed how I received the data from the database. Like this is how the data looks. Like this is the raw data. So as we can see, the whole, like, for me, this is the valuable part. Oh, sorry. This is the valuable part. Like all the values under this data column, and node ID is also node ID, timestamp, and data. The version and ID, we don't care about that. We don't need that. So I have developed code to convert this data and map the values accordingly, which I'll show later. So this is how the data will look after transform, like after taking the values out of this list, and then you map those values accordingly. And we have a document already available with us, which had all the nomenclature of various sensors, nodes, and everything. So mapping wasn't much of an issue, but rather taking out those individual values from that list was a huge challenge. So as we saw earlier, like there's a lot of missing data, right? So first, I want the audience to understand that the sensors send null as well as zero values. Sometimes, rather than sending a null value, the sensor may send a zero. Taking this randomness into account, I've developed code for cleaning which performs the following tasks. It will detect string null and then replace it with the mean of that attribute of the data if the percentage of null values is less than a specific percentage. So I think that anyone who has worked in like this field of data science like knows where I'm heading with this. Else the null values are dropped. So as we do in any project in which we encounter null values, we see if that attribute has a huge number of null values missing. Either we like drop that whole attribute, or what we can do is if the percentage of null values is less than a specific threshold which we can define, then we can fill those using either the mean or median. Similarly, I have done for the zeros value as well. If there is high variance, then the median is used, else we'll use the mean. So, as discussed earlier, the queries are written in PostgreSQL to obtain different kind of visualizations, like time series graphs, comparison of predicted and actual values. I've also added the predictive values for humidity and temperature for approximately 5 days using the Open Weather Map API and integrated it directly with Grafana. So like this is also one of the reasons we use Grafana, because it supports a lot of third party libraries, and all these tasks are performed locally, but the website can be deployed easily as we already have other dashboards running, and the queries are written in such a way that they are consistent with the main database which we have used uh, for the dashboards that are already running. So now comes the interesting part, the final dashboards. We can clearly see some patterns like how relative humidity and temperature are negatively correlated. At night, when temperature goes low, the humidity increases. The model predictions part of the dashboards was built using dummy data, as at the time of making this report, the DL model was still in development. For the prediction part, for the prediction dashboard, the API used was down at the time of making this presentation, so I couldn't get the snapshot the way it should have been. So this is how the analytical dashboard looks. Okay, as we can see here, when temperature is high, the solar radiation is also high. Okay, whereas when the temperature is high, the relative humidity is low. And I have also shown the ESG part of like our dashboards, like how much I can basically select here the time frame. Like I can drag this and a time frame will be made for which the carbon footprint saved will be calculated and the carbon saved will also be calculated. So like how much carbon we avoided being released into the atmosphere by using solar energy, and how much carbon we saved from burning is shown here. And this is the energy generated today. So ESC today is like the actual values of how much energy was generated. Okay, and the predictions is what the model has predicted. And this is the forecast dashboard. So as I said earlier, the API was down at that time, but this dashboard is just for the forecast part, and the ESG part of the previous dashboard is also included here. And that is it. Thank you everyone for giving me this wonderful opportunity to present my project. Thank you.